Thank you, Michael. Check.
Hello.
Check.
Hello.
Check 1, 2. Yeah. How you guys doing tonight? Right. We are Astronomy on Tap. So tonight on stage we have Michael. Make some noise for Michael. So we have the IT team over there. We have Adam. We have Brian.
Woo!
Thank you, guys. We have Aaron, who recently joined us. Thank you, Aaron.
Woo!
And tonight we have an old host who came back. Thank you, Sam from Austin. Make some noise for Sam.
Woo!
And my name is Vincent.
Woo!
So there's a lot going on these days with James Webb. I don't know, probably some of you guys have followed this. James Webb with incredible pictures. We have Juno, who flew by Europa recently on September 29th. Europa, which is one of Jupiter's largest moon. And tonight we're going to talk about DART. Yeah. So raise your hand if you have heard about DART.
Ooh.
All right.
That's a good.
Yeah, that's awesome. That's awesome. I'm very excited about this talk. So, Michael, you want to say a few words or?
Sure. There's background music. I don't know if you hear. I don't know if it's coming out of your computer.
There's probably some space sounds on my computer. Yeah.
Well, that'll just be there. Well, welcome everyone. Thank you for coming. We're pretty much. It's glad to be back in the groove of things. This is, as you see, the 6th Astronomy on Tap since we resumed in May. So this is great. Thank you all for showing up. See a lot of regulars out there. How many of you, this is your first time here in person? Wow, fantastic. Well, thank you for coming. I hope you enjoy.
Awesome.
Can start a little bit about ourselves, what we are, what is Astronomy on Tap. It's a global phenomenon, as you can see on the globe. But really all it is you have speakers who come in and give a talk about their topic of interest, and then you can ask them questions and learn all about astronomy. And every city seems to go well, and especially here, so we're happy to have you.
Next slide. So this is just to show you how much fun we have over here. But that was before the pandemic, so I hope you guys are gonna enjoy as much as we used to. And tonight we have a lot of great prizes to win. Robert. This is mine. Hello. All right. At the end of the talks, there is always trivia questions at the end of the night, and we've been granted those incredible 2020 Night Sky Almanac 2022. So there's a lot of those prizes to win. We have posters. We have NASA stickers. I'm sorry for the feedback. So stay tuned. The trivia questions will be about the talk. So what's going on? I think we can.
Woo!
This is science. All right. Next slide.
All right, so tonight we have 2 great talks as usual. Our first talk will be given by Dr. James Walker, will be about the DART impact, so very exciting. And once again, we'll have the Q&A afterward. The second, then we will go on break for 10 minutes. You can order drinks and some food. And of course, our merchandise table here is all full. And as promised, we've got shirts and mugs once again, or pint glasses once again. So very excited. So
they are back.
Come check them out. And then when we return from break, we'll have Caleb Gemar with Astronomy in the News, going over this month's exciting astronomy. And then we will round our evening off with Samantha Toback, speaking about Archeoastronomy, digging in the dark, which will be a fun history lesson of night sky observing. So 2 great talks, and of course we'll get started with introducing our
I'll hand you the
speaker.
microphone.
So, as talked about at the first talk, Dr. Walker is the director of the Engineering Dynamics Department and an acting institute scientist at the Southwest Research Institute. Among his recognitions is a Best Paper Award at the 2012 Hypervelocity Impact Symposium for a paper studying the size-scaling behavior of momentum enhancement. He is author of the text Modern Impact and Penetration Mechanics, published by Cambridge University Press in 2021. He's a fellow of the American Institute of Aeronautics and Astronautics, a fellow of the American Society of Mechanical Engineers, and a ballistics science fellow of the International Ballistics Society. He is a former president of the Hypervelocity Impact Society and is currently president of the IBS, the International Ballistics Society. So for the DART talk, please welcome Dr. James Walker. Yes. Oh. One thing, as is tradition, for those of you who have been here and those of you who are new, we have a key word that when Dr. Walker says the word, you'll have your drink and you'll give a little cheer, woo, with your drink and take a drink. What is your key word today?
Well, I was suggested I pick the word something like the, but
we want them to get home.
So we'll have an equivalent word. It'll either be momentum enhancement or beta, which is the Greek representation of it.
There you go.
Beta or momentum enhancement. Okay.
All right, take it away.
So I'll tell you a little bit about our involvement in the DART mission and what we've done at Southwest Research Institute and what the purpose of the DART mission is, what we're hoping to measure. And so we'll have a little build up to what happened, and then we'll talk a little bit about what happened, though so far no numbers have been released. They're still in the embargo stage, so I can't really talk about that, but we'll say what's happening. So these are some co-workers at Southwest that I work with. We have people both in San Antonio and in our Boulder office that are involved in impact on celestial bodies. It's a big team. You'll see I'll switch between kind of white slides, which are my plain slides, and the DART team has pretty blue slides. So you'll be able to tell the difference of when I put a slide together or when the team put it together. So I work at Southwest Research, as was mentioned. Thank you. Yes, and just a few days ago was the 75th anniversary at Southwest. On September 19th, that represented 75 years. So the Chelyabinsk meteor entry is part of the issue here of what happens if something's coming towards Earth. Is there something we can do about it? So this was a meteor that was backed out to be about 20 meters across, going about 19 kilometers per second. So it's the kind of speeds that we're talking about. We also had another reminder in my lifetime, and for some people in here, their lifetime, though some of you look pretty young, so maybe not in your lifetime, but, and that's when the Shoemaker-Levy 9 comet struck Jupiter. That was also very interesting that we saw it about a year and a half before the comet struck Jupiter. And this is Hubble's telescope as the comet broke up due to a close flyby of Jupiter and then was in an orbit that came back. And it struck Jupiter about 60 kilometers per second, 60 kilometers per second. And this is an image from Galileo, which was the only view we had of the actual direct-on image. So this is the impact flash from that strike. And this is one of the strikes with about a kilometer across piece, we think. And you can see the time. You couldn't see the image from Earth, but you could see the plume up above the horizon. That's what you're seeing there in the bottom. And then we go to hour and a half later, then 3 days later, then 5 days later, looking at the ash that's in the clouds of Jupiter. And so for a kilometer-sized object, the ash that was in Jupiter's clouds was about the size of Earth in extent, so pretty large. Unless we think that's the only time those kind of things happen, back in 2009, someone saw a dark spot on it. An IR telescope was aimed later, showing that it was glowing hot, so we know these kind of things happen. And so that's kind of the motivation for DART is, what if something big were to come towards Earth? Can we do something about it? So a famous case is Tunguska, and this is a computer simulation of the blast wave of what might have occurred. That's in the 1900s. If you go back further, we have the meteor crater. And if you want to go back even further, we have the impact in Mexico. What's different about a meteor or a comet nucleus striking Earth than other natural disasters is it something we could maybe do something about. You know, when you talk about a tornado or a hurricane or an earthquake, even if we knew it was coming, all we could really do is move people out of the way. We don't have anything we could do about it. But if we have some warning for a celestial body that's striking Earth, and it's small enough, you know, which could be on the order of maybe, 20, 50, 100, 150 meters across, we could potentially deflect it. And how effective we are at that was part of what was the objective of the DART mission, to understand that better. So our involvement in small bodies has really been looking at the question of what are they made of, what are they like on the inside, are they a solid piece, fractures, rubble pile, or even just gravel sitting there. And these questions about structure also affect what you might do to deflect the object, to better understand how we do it. So at Southwest, years ago, we were looking at seismology on these objects and how we might be able to tell what the interior looked like. And through that, we saw interesting things that had to do with scale, which I don't really have the time to get into tonight, but are really quite interesting. The things at small scale in the lab behave differently than things at large scale, which is really quite an interesting phenomenon. The first intentional big impact that we did in the space science community was the impact of the deep spacecraft, deep impact spacecraft into the comet Tempel 1. And that was back in 2005, and Southwest Research built the flight control computers for this spacecraft. And this one was intended to be an impactor, so it had a copper, kind of almost a sphere of copper that was in the impacting spacecraft, which is what then, this is the picture of the impacting spacecraft coming into comet Tempel 1. And of course, when it stops, that's when the impact happens. And then there was a flyby spacecraft, which then shows the debris all coming out. And it's very bright. This brightness is due to the reflection off the sun. It's not an inherent brightness due to the impact in these actual images. But you can see the debris coming off. This impact was at 10.2 kilometers per second, which is getting the range of about 22,000 for speeds. Okay, so look at momentum enhancement, right? Our favorite word. That's right. So momentum enhancement is usually indicated by beta. This is going to be a hard slide, I can tell. And so when we strike an object, especially at really high speeds, we form a crater, and that crater throws off a lot of debris. Because of that, we get more momentum delivered to the body than we actually brought with our impactor. And so this is the central question of the DART experiment, is how much more momentum at large scale. So we have the impactor here. It comes in with its mass times velocity. We have what the change in momentum is of the impacted body, and that's what's called the momentum enhancement, or beta. That's right. Okay, so here's an experiment we did about 12 years ago, where we took a large granite sphere, and this is about a 4 centimeter aluminum sphere. We have a variety of launchers or guns at Southwest Research Institute. This is a powder gun, and we did a test at about 2 kilometers per second, which is about the fastest you can do with a powder gun. That's about twice the speed of a rifle, a little more than twice the speed of a rifle bullet. And we always do calculations ahead of time. I'm not going to show lots of calculations tonight, but I don't want you to walk away thinking, oh, they just shoot and wonder. These calculations were done ahead of time. So these are some stills because you're not going to be able to see the initial impact flash where all our stuff is saturated, and then the initial debris cone, and then there's the later development of the ejecta curtain that happens. But here's the video. And so all that debris that you see that's flying back in the direction of the projectile that came in is imparting more momentum to that granite sphere going the other way. And so how much more is the momentum enhancement, or beta? And in this case, beta is over 2. So we more than double the amount of momentum that's transferred to the object. I wanted to point out in our calculations, you notice that in the impact test there was a little bridge there. And notice we had a little bridge in our pre-test calculations, right? We like to model these materials. Well, if we want to go faster, you have to go to bigger equipment. And at Southwest Research Institute, we have a large 2-stage light gas gun. This is a photograph of it. It has its own building. It's the single largest piece of experimental equipment at Southwest Research Institute for a single item. This is our group that works on it. So the idea of a 2-stage gun versus a single-stage gun is we burn the gunpowder in this chamber. It drives a piston that compresses hydrogen. A diaphragm fails here and launches the projectile. Hydrogen is the light gas. It's the second stage. And the reason for having a light gas is because you need a gas with a really high sound speed, because otherwise the projectile will outrun the gas. It can't transfer information to the back of the projectile any faster than the sound speed of the gas. Hydrogen has the lightest sound speed because of its low molecular weight. So that's why it's a light gas gun. We sometimes use helium, but to go really fast we use hydrogen because they differ by a factor of 2 in their molecular weight, which translates into a factor of a square root of 2 in the speed that you can achieve driving them. We have lots of diagnostics on our shot line. We do calculations of the test, just showing, fracture, how the debris is formed. We look at this. I don't have time to really talk about all this. So these are some powder gun shots, and then we'll look at a really high-speed shot. Concrete, sandstone. So you can see the momentum enhancement here is about 2 for 2 kilometers per second. Various targets. We also do pumice because there's a lot of speculation that some of these objects will have very low density. And that reduces the momentum enhancement because when you open up a crater, you don't constrain it and force it back out the other way. You can push it to the side. So that reduces the effect. Okay, some more calculations. Okay, so here's one, though, that's directly related to DART. There's a lot of discussion that asteroids are perhaps rubble piles or just gravel conglomerations. So we did a test where we took small stones. The way we measure the momentum enhancement is by a pendulum that swings. So we have to hang it vertically. We can't avoid that aspect of it. So to hold our small stones in place, you see we put some cement there to hold the small stones in place when we hung them. And so because of adding the cement, our density is higher than what the estimate is for Didymos, the parent body, 2.92 versus the 2.17. So it's somewhat of an analog. We put it in our pendulum. We put it in the target chamber, an evacuated target chamber, our 2-stage light gas gun. We put in a mirror so they can watch what happens. These are stills from that impact, and here's the actual impact at 5.44 kilometers per second, which is about a little over 11,000 miles an hour. And we just have debris after the fact that we can then clean up to see how much stuff was ground up. But the pendulum in there swung, and by measuring the swing on the pendulum, we're able to back out how much momentum was transferred, and you'll see that for this test, the momentum enhancement was 3.4. So a beta of 3.4. So in other words, you hit it with a projectile going at us with a certain momentum, and you got 2.5 times as much more momentum transferred to the target than the projectile, the impactor, brought with it. Well, what about the DART mission? So it's a large-scale test. We're interested in the effects of size scale. It's got some downsides. The impactor it's just a spacecraft. They didn't have an impactor part to it to kind of model a nice impactor like we do in the labs. So it's a distributed spacecraft with its various components. It's about 2 meters on a side. And of course, we don't know about the impacted body. All we know at the time, in fact, a week and a half ago, we didn't know anything about the impacted body except for it existed. So this is the discovery of Didymos, which is the parent body. And so the idea of the test was, well, we have this parent body. It was later determined there was a moon, and if we impact the moon of Didymos, we currently know how long it takes for the moon to go around, almost 12 hours. If we impact the moon, that will change its orbit and it will change the time to go around, which we can then determine from the Earth what the change is just by the light curve analysis. So this is Didymos. This is an estimate picture. We do know, this is Didymos. This is Dimorphos, which was the moon, about 160 meters across. We knew there was a moon, and you can see the moon there. We also know the shape of Didymos because of those. And because there's a moon going around it, that's how we know the density of the asteroid Didymos. That's what Didymos looks like. So the purpose was to impact and to measure beta. There, that's the purpose. Okay, so here's some fancy pictures. There's the spacecraft in construction. It was launched on a SpaceX Falcon 9 out of Vandenberg, Space Force Base. Used to be Air Force Base, now Space Force Base in California. So here's the launch, which was the week of Thanksgiving last year. So there's the launch. So it actually, is pretty recent. And now here's the separation you'll see where the spacecraft separates from the payload fairing on its trajectory. This should happen shortly. So you can see the spacecraft as it's put on its trajectory. And it's essentially a ballistic trajectory with some adjustments from this launch. So there's the spacecraft on its way. It then deploys those large solar sails that you see in things. My colleague, Sydney Shulkran, was able to attend, and our families, my daughters, his daughter, and our wives were able to go and watch the launch. So that was pretty exciting. So there's lots of stuff up there, but this is the idea of what's happening with DART. We come and we do a launch from Earth. The DART spacecraft is launched. It's going to go on this trajectory. You see Didymos, which is a near-Earth object, meaning it passes within 1.3 astronomical units of the sun. And you'll see that it's the DART spacecraft is fairly close to Earth on its entire trajectory, and then they will come together at a distance of about 1/10 of an astronomical unit apart. So it was about 45-second delay in communication between the spacecraft and Earth at the time of the impact, which was just last Monday night. This is showing what the idea is. We have it going around Dimorphos, which is the moon, going around Didymos, which is the primary, which is about 780 meters across. They're about 1,200 meters apart. And we're watching that with from Earth to determine what the time is. We do the impact with the DART spacecraft. There was a follow-on spacecraft called the Licia Cube, which came behind it, and that adjusted the orbit, put it into a more elliptical orbit, but it now has a different period, and based on the different period, we can determine what the maximum speed is there at the change in speed there at the point of impact. So and the way we know that is by light curve measurements. It's too small to see from Earth, but the idea is that we can see how when the satellite, the moonlet, Dimorphos, goes around, it either adds more light, like here, or it's in front casting a shadow with less light, or it adds more light, or when it goes behind, then it's no longer being reflected and there's less light. And so we have this information that's in the light curve, which tells us how long it takes the moon to go around. And this is all speculation. We have telescopes are currently observing, and data is being collected, but I won't be able to tell you what the change is. There's a preliminary number, but it's embargoed still. NASA hasn't allowed the release of the number. And so you can see that's what we're trying to do, is we're trying to figure out what is the change, because that will allow us to know what the change in velocity was of the moon. And lots of telescopes on the ground are looking at it, and in space, the James Webb is looking at it, the Hubble's looking at it, and also Lucy's, I'm told, is going to be doing some observations. So here's kind of a fancy, glitzy computer graphics simulation of what it looks like. So there's the spacecraft as it separates. You saw the real separation just a moment ago. The solar panels deploy, and then it's on its roughly 10-month voyage to the impact. There was only one scientific instrument on the spacecraft, and that was the telescope. There were no other measurement instruments on the spacecraft. And so all the data we have from the spacecraft comes from that telescope. And of course, so we know when the spacecraft hit, when those images stopped streaming back. So that was when we knew this is what's called the Licia cube from the Italian Space Agency, which was a CubeSat that followed and took some pictures. And then it was all on autonomous control for the last few minutes. And the impact speed was a little over 6 kilometers per second. Well, I had some other videos, but let's see. So the DART impact was last Monday night. There was a nice mnemonic for those of us here in Texas. It was at 6:14 p.m. and it was at 6.14 kilometers per second. And that's about 13,700 miles per hour. And this is what the images we got back coming in. So this is Didymos, the main asteroid. This is Dimorphos. So this is the first time we ever knew what it looked like, was in the last few seconds before impact. And then it ended, right? That was the end. So this is the last image we have where we have Didymos in the image. This is the last image where we have fully Dimorphos in the image. And these are the last two images that we got. The one from 12 kilometers out, remember, was a telescope, and the one from about 6 kilometers out. So this box corresponds to the last image size, but it didn't finish transmitting. So that's what we got, was just kind of the top. And if you look here, you can see features and how the features match up. And then this little box here is the size of the DART spacecraft, about 2 meters on the side, about 6 feet on a side. It was also seen by ground-based telescopes. So these are 2 images from ground-based telescopes. Each of them runs roughly half an hour. These images showing the strike and the ejecta that came off of Dimorphos from the impact. So you can see there's a fair amount of ejecta. It's actually a little hard to estimate the ejecta. That's part of what's going on right now. But because it's very fine ejecta, it reflects the sunlight very well. Same with what happened with Temple 1. And the same thing here. We have ejecta coming off the strike. So I mentioned Hubble and Webb. We're also looking at it. So these are the Hubble images. As you can see, before the strike, right after the strike, 5 hours, 8 hours, and they animated it, though it's just 3 images showing the debris that's coming off. The bright light here is Didymos, the primary. And Webb also, roughly a sequence that's lasting roughly 5 hours after the strike. The Italians had a cube that flew by, this Licia cube, and this is an image from Licia cube showing the ejecta and streamers coming off from the strike. So that was the mission, and DART hit its target. I'd like to tell you what beta was, but we're in embargo stage right now, and but we in our lab tests got 3.4 for a rubble pile type assembly. So thank you. Are there any questions?
Thank you. Great talk. That was pretty interesting. So yeah, if you have any questions, it's better if you want to text them, or after we went through all the texted question, you can shout your questions. But again, make some noise for Dr. Walker. That was really interesting talk. So I got a question here about. It sounds like the moon of Didymos was detected in 2020. And the spacecraft was sent in 2021.
So I apologize. I don't know what year the moon was detected, but I know the initial mission discussions about hitting Didymos's moon were in 2011. So for sure it was known it had a moon. Well, and actually the pictures I showed from Arecibo were 2003.
Yeah.
So for sure we knew there was a moon by 2003.
Okay. Yeah, I think. So another question was, is it better to destroy the object or to redirect it? What's the better strategy for planetary defense?
So this is actually a hotly debated topic in the planetary defense community. And so I'll tell you what the argument for not destroying it is, and then I'll let you draw your own conclusion. The argument for not destroying it is the concern that if you try to destroy it and you fail, you may have a really big piece still headed towards Earth. Whereas if it's all contiguous together and you successfully nudge it, then you know you nudged the whole thing, and you don't have a large fragment that you ended up not deflecting very much. So that's what the argument comes down to, whether you think you could actually demolish the whole thing. So that's a different word. That's a different word. So we have planetary defense, which is protecting Earth from objects striking Earth. There's planetary protection, which is protecting Earth and other planets from microbes. Right? So that's very special. You need to be very careful if you hear the terminology to make sure you're in the right conference room for the talks you want to hear. Right? So planetary defense is the impact crowd. Planetary protection is did we use UV light to kill all the little germs before we loaded the spacecraft onto the payload fairing. So I'm not sure what you mean in the sense, how do they feel about it?
So does planetary protection ever have concerns about the asteroid environment and objects that, while they aren't posing a direct threat, that we basically leave them alone, or would another test like this jump through certain channels?
So I think the gist there is right now most people's models of how life survives don't include it surviving on asteroids, and so because of that, there's been no real interest, as far as I'm concerned, beyond just the standard clean room handling of spacecraft, of any other concerns.
All right, I got a last question. So you've showed asteroids with different composition, and so would a rubber pile-made asteroid pose more danger for us if we kind of blow it away compared to a more solid object?
So the real interesting question here really is, which one has the greater momentum enhancement? Because that makes it the easier one to deflect. And that's part of what we're hoping to tell. We can tell by the pictures here that this is a rubble pile, if not a gravel conglomerate, right? It's clearly broken up into very small pieces, though if you remember from the picture that we looked at, there is a big boulder near where the impact site was, right? You can see there's a relatively large boulder right here, right near the impact site. But the real question becomes, if it being a rubble pile allows more debris to come off faster and more momentum enhancement, then you are more effective at deflecting the asteroid. However, I will also say we've done tests with solid rock, and we get very good momentum enhancements with solid rock.
Really cool. Well, thank you. We thank you very much for protecting the Earth anyway. So, thank you. Awesome talk again. Thank you so much. So we're going to take a short 5-minute break if you want to order more food, more beer, and we'll be back in 5 minutes. So, oh yeah, we have merchandise here.
All right, well, good evening, everyone. So I have the astronomy news for this evening for you, so we will go ahead and begin with that. First and foremost, what is up in the sky for October? Well, just like last month, we have prime viewing of Jupiter and Saturn in the sky. Do not miss them. If you go out and look toward the southern half of the sky, this is around about 10 o'clock p.m. for about mid-month. You will find both Jupiter and Saturn toward that southern half of the sky. Jupiter will be very, very bright. You cannot miss it. It sticks out like a sore thumb. Saturn, a very bright star-like object as well, although a little dimmer. So just remember, for the most part, the planets do not appear to twinkle when you look at them in the sky, unlike the other stars. Now, if you're in a really nice dark location away from city lights, bring a nice pair of binoculars with you, a good 7 by 50 or 10 by 50 pair of binoculars, and look right about here, just off of the constellation of Andromeda, and you'll find this little gray fuzzy spot in the field of view. That is the nearest galaxy to our own galaxy that is similar to our own galaxy. It is the Andromeda galaxy at about 2.5 million light years away. So you're looking at it as it appeared about 2.5 million years ago. Great sight to find in the sky. Again, very easily found under very dark skies. Now, if you missed the news today, a crew launched to the space station today. The NASA SpaceX Crew 5 mission launched to the space station today, the International Space Station, at around noon time. This crew consists of 2 American astronauts, Nicole Mann and Josh Casada, a Japanese astronaut, Koichi Wakata, and a Russian cosmonaut, Anna Kakina. So, good journeys to them as they head on to the space station today. Now, many of you have probably heard that just last week, the Juno spacecraft made a really nice close flyby of the Jupiter moon Europa. Yeah, indeed. All right, I figure we had a few Juno folks in the room here. So, the big deal about this is that this was a very close approach. This is the second closest this spacecraft has ever approached to Europa. The closest was by Galileo back in the 90s. This was a 218-mile approach. This was a 222-mile approach. Oh, what do we know? I have a nice example of Europa here. And Europa is this nice icy moon, mostly ice surface, probably has a liquid water lake beneath it. So a very fascinating world, especially for those that are looking for possible traces of life beyond Earth out there. Here you go. Thank you very much. And it will be very encouraging to see the data that comes from this close flyby during the coming months and years. And these are actual images from that flyby where you can see in very nice detail that icy surface with some of those nice ridges and albedo variations on the surface. Now, many of you have probably seen this image. Really great image. James Webb Space Telescope imaged the planet Neptune, and this is the probably one of the best images that we have, if not the best, of the rings around Neptune. They're very, very hard to pick up. They can be picked up by the Hubble Space Telescope, but it's not nearly this clear. So yes, this is probably one of the best views that we have of the rings of Neptune. And again, Webb specializes in that because it can see in that infrared band that those rings glow in so well. In this image, you can also see many of the moons of Neptune, including its largest, Triton, right there. So I encourage you to go online and get a nice, good, close look of that image. Now, the Webb telescope did take a look at a closer target, the planet Mars. Maybe not quite as picturesque, but what's very, very interesting is that Webb was able to pick up the temperature differences between the leading hemisphere of Mars looking dayward and the trailing hemisphere of Mars, and also, of course, a variation in the ability of its surface to absorb heat radiation there at the Hellas Basin. So a really, really fascinating image of Mars return from Webb in that sense of what it actually shows us about the dynamics of the planet. So do not miss coming up in the next month here. In fact, maybe a little longer down the road. Solar eclipses in 2023 and 2024, an annular eclipse in 2023. So if you have those eclipse glasses, you'll see something that looks a little like that, where the moon doesn't quite block the sun entirely, but it makes this nice little circle in front of the sun there. And then in 2024, the really big deal, the total solar eclipse, where you can actually see the corona of the sun. Make sure you're in a good, nice spot, kind of northwest of town, as that takes place this coming 2024. So do keep that in mind. We do have a First Friday stargazing coming up at the University of Texas San Antonio. The observatory up on the roof of the Flound Science Building starts around sunset. I will be there. Don't miss it. We have a really great time up there being able to see a lot of what is in the sky. You will be impressed. I guarantee that. And then Space Launch System will be launching eventually. It will happen. As I said last month, you could wait for Webb, you can wait for Space Launch System, so probably coming up this November, all right? And that is the astronomy in the news segment. Thank you very much.
All right. Yeah, that's good. Thank you. Thank you very much, Caleb. Yes, I can vouch the first Fridays are always a good time, especially when the weather is crisp and beautiful. You go out there and you can see a lot. So just quick, some upcoming events that we have. I will say something that we just had over the weekend on the October 1st, Saturday, was International Observe the Moon Night, our moon right here. We actually, the Astronomy on Tap team, had a little table at the Scobie Education Center. It was a great time getting to meet people and educate people about our moon. And so when you all come up afterwards, we have some 3D models of the moon's surface you can check out. And then in the spirit of today's talk, we have asteroid 3D prints of asteroids and comets and stuff. So just, fun stuff to look at. Look, well, yeah, you can touch, don't take. I'll look. Also upcoming is the El Dorado Star Party from the 24th to the 29th this month. Conveniently, I'll be gone. Damn, darn it. This looks a lot of fun. I mean, first of all, look at where it is. That's a good place to look at stars in Texas. Not a lot out there. We have, in this very room, our own Vincent here will be giving a talk there, and many of you remember has given a few talks here. Robert Reeves will be giving a talk there as well. He's in the room. So there he is. And unsurprisingly, he took that picture. All right, and now to introduce the next speaker, here's Aaron.
All right, so our next talk is going to be Samantha Toback, who is... She is an informal educator with a particular fondness for astronomy, wildlife, and history. She loves helping people learn about and make connections with the world around us, whether it's in ground under our feet or in the skies above our head. Samantha has a list of astronomical events that she has wanted to witness since she was a child, being a solar eclipse, the aurora borealis, and Halley's Comet. She has seen the first two and is patiently waiting for Halley's Comet to return in 2061. Only 41 years to go. Everybody give it up for Samantha Toback.
I can talk really loud, but I don't want to. All right, so hello. My name is Sam, and I'm going to be telling you about Archeoastronomy, digging in the dark. But this is going to be a very interactive presentation. So if you have a cell phone, I want you to whip it out, go to menti.com, and enter that code. That code will be on a few other slides as well, so if you aren't able to get it before we move to the next slide, that is okay. I promise you'll catch up. Yeah, so the code is 55451816. Oh, yay, you guys like my slide. Look at all those little hearts. Oh, my drinking word, sorry. My drinking word is peoples. The peoples that we are talking about tonight. So you're gonna hear me say that quite a bit. All right, go ahead and take us to the next slide. Now, I want to start this by giving a land acknowledgement because we are all on native land. Here in San Antonio, we are on the land of the Humanos, the Tonkawa, and the Coahuiltecan peoples. Now, a lot of these peoples have not ceded this land, so we are on stolen land right now. We are talking about ancient cultures, and these ancient cultures are still here today. They are our neighbors, they are our communities. So when we're talking about archaeoastronomy, I want you to think about the current modern day connections that many of these cultures still have. If you are in the mood to be a giving person tonight, a really great organization here in town that you can support is the American Indians in Texas at the Spanish Colonial Missions. I suggest checking out their programming. They do a lot of really awesome programs throughout the year, and they do a lot of work to help support Indigenous folks here in San Antonio. Next slide. About me. That's me. I have a very interesting mix of passions and interests. So I have a bachelor's degree in history with a minor in Spanish. I was an astronomy TA for 2 years in college. I was also the president of a band organization. I was in the marching band and in the concert bands in college. I play French horn, flute, and percussion. After graduating, I was like, what can I do for work? Oh, the sound got weird. Cool. Oh, it's back. Okay. So after college, I was like, what can I do? And I started working at the Whitty Museum. So I worked there for 5 years in the education department, helping people learn about Texas from prehistory from paleontology all the way to today. So dinosaurs, ancient peoples, Texas wild. Oh, there we go. I love that. Vaqueros and cowboys, health and wellness, a little bit of everything. After that, I went to the San Antonio Missions National Historical Park, and I was their community volunteer ambassador. Hey, I got some folks there. Helping people volunteer and connect with the national park that is in your backyard. How many of you knew that there's a national park here? Yeah, it's free. Go check it out. It's really cool. And then I was also helping organize Astronomy on Tap for a while. I was volunteering with Texas Parks and Wildlife, and then Texas Parks and Wildlife said, hey, you want a job? And I said, I sure do. And so now I work for Texas Parks and Wildlife as the Ambassador Program Coordinator, helping people connect with our state parks and helping them find service through the outdoors. So again, I do a lot of different things, but I'm not Charlie Day. This is what I look like. Phil, go ahead and hit next slide. All right, here's where Menti comes in. Oh, I'm so excited for this. So again, menti.com, 55451816. I want you to type in, what do you think of when you hear the word archaeology? All right. We'll give it a little bit longer. I love that one. Awesome. So we're seeing a general trend here, right? Something that's old, stuff that's in the ground, rocks, dirt, sand. We do see dinosaurs a few times, though. And I'm going to have us go to our next slide. Indiana Jones. Yes. Okay, so what is archaeology? Archaeology, if we look at the definition, is the scientific study of historic or prehistoric peoples and their cultures by analysis of their artifacts, inscriptions, monuments, and other such remains, especially those that have been excavated. So if you put dinosaurs up there, you are thinking paleontology, not archaeology. Good guess, though. Now, the reason I'm doing this particular talk tonight is because this is Texas Archaeology Month. How many of you knew that? Yeah. Well, now you know. So Texas Historical Commission and various other archaeological organizations in Texas have a lot of different events going on this month focused around archaeology. They have informal events, formal events, fancy talks, go dig in the dirt, lots of really cool opportunities to learn about the peoples and cultures who are found right here in Texas. Now let's go ahead and go to our next slide. This one's a little bit easier, so I'm not going to make you guys guess. What's astronomy? I have a feeling that one's a little bit not as difficult, right? The science that deals with the material universe beyond the Earth's atmosphere. If it is up there, it's astronomy. Go ahead and hit next for me. Oh, this is fun, because my dad's in the corner there. So what is archaeoastronomy? This is a picture that I took with my dad, that little silver blob, when we went to Stonehenge a few years ago. So archaeoastronomy is the branch of archaeology that deals with the apparent use by prehistoric civilizations of astronomical techniques to establish the seasons or cycles of the year, especially as evidenced in the construction of megaliths and other ritual structures. So Stonehenge is a great example of an archaeoastronomy site. But how do we know that these alignments are intentional and not coincidental? How do we know that these people built these buildings or these structures or made this art with the sky in mind? So that's the question I hope to answer. Let's go ahead and hit next. Ooh, look at all of them. Go ahead and hit enter for me. The faster you answer, the more points you get in these little quizzes. The prize is a high five. So, what astronomical objects or events can be observed with the naked eye? You got 30 seconds. Well, that's going. I'm gonna get water. Time's up. Ooh, look at that. So we have quite a few answers. The correct answer is a lot of things, right? But let's look at some of what people put. We had comets, planets, the moon, eclipses, the sun, stars, and shooting stars. Menti only let me put a certain number of correct answers. You're all correct, though. Good job. Give yourselves a pat on the back. Yeah. All right, next slide. Now we're going to start off by talking about Chaco Canyon. Go ahead and hit next for me. Chaco Canyon is found in the northwest corner of New Mexico. It is a national historical park, much like the San Antonio Mission's National Historical Park. And it is a place you can go and visit and walk around. Go ahead and hit next for me. We're going to focus in specifically on one structure called Pueblo Bonito. Now, Chaco Canyon was a center of civilization in various points of history. I'm going to double check my notes here so I get the dates correct, because nothing is worse than saying the wrong thing, right? So this particular structure and the general Chaco Canyon culture, these peoples, were building these structures and inhabiting these structures from about 850 to 1250 AD. So when you think about it, not that long ago. Definitely a little bit longer than I've been alive, but yeah. So these structures date back to about that time. Now, the peoples who lived here are the ancestors of the modern-day Hopi and other Puebloan tribes. So again, these people are still here. Yeah. They just don't live in Pueblo Bonito anymore. Now, one of the things that you'll notice is that there's a line right down the middle of it. And if we look at the little label up in that top corner, that center wall is aligned perfectly due north and south. So right smack dab in one direction. Now, this is particularly interesting because how do we know today which direction is north? What's an easy way to go outside and say, oh, that way's north? Polaris, right? Polaris is right there. Well, not right there. I think it's that way right now. But that is a really, really easy to use tool, right? You can go outside at night and you can look around and go, oh, that way's north. And it gives you a pretty solid exactly due north-south. However, when Pueblo Bonito was being constructed, Polaris was about 5 degrees from where it is today. So they could not go out there and go, oh, it's right there, right? Go ahead and hit next slide for me. So one of the things that's really fascinating about this is this shows us that these peoples were observing the sun. You can tell which direction is north if you look at the zenith. Where is the shadow pointing when the sun is at its highest point in the sky? So if you'll go ahead and hit play for me. We can see that as time goes by, that shadow is moving, it's moving, it's moving, and eventually the sun hits its zenith, and it is pointing perfectly north-south. Now, the fact that this building has that center alignment is a very telling sign that these people are observing the sun, right? We can see that this happens every single day that we have sunlight, and the fact that that line or that wall is lined up so perfectly is a good indicator that that is an archaeoastronomy site. But wait, there's more. Go ahead and hit next for me. One of the other really neat things about this particular structure is that if you stand in the southeast corner and watch the sunrise every single day, from about the summer solstice through October 29th, the sun will rise along edges of the canyon that are very jagged. So you can tell the movement of time very easily by looking and seeing, oh, it rose over next to that particular jagged part. That means it's this time of year. After October 29th, though, the sun starts to rise in a section of the wall that is perfectly flat on the canyon. There's not a lot of really good indicators of where things are happening. And at Pueblo Bonito, in one of those circular rooms, which are called kivas, on October 29th, there's an upper doorway that is way off the ground, doesn't quite make sense there, and light shines through, starting October 29th through the winter solstice. And that light illuminates different parts of the room throughout different times of the year. Again, is this intentional or is this a coincidence? One of the neat things about this is that we do have people that we can ask. Of course, we want to be respectful of their culture and their knowledge. And so, again, I'm not an archaeologist, I'm just a nerd. And so I can't really go up to somebody and be like, tell me all of your secrets. But that is a really, really telling sign for us that this is most likely something that has been researched by these peoples, right? Hey. All right, go ahead and hit next for me. So here you have another image of this beautiful, beautiful structure. Again, the Hopi people are still here today. They still make these observations. Many of their rituals are based around the sun and based around the cycles of the sun and throughout the year. And we can see that direct connection, right? If the people who came from these people are continuing to make these observations, then we can use anthropology to say it's very, very likely that that was a very intentional structure. That perfect line north-south, that window in the wall, it's very likely that that is archaeoastronomy in action. Go ahead and hit next for me. Another quiz. Press enter. Answer fast. Pueblo Bonito was the largest building in the continental US until the 1800s. Is that true or false? Ooh, I can get more water. That is true. Once again, These people are very intentional in how they build these structures. This is a massive building. It is about the size of the Colosseum. It's not small by any means. There's over 80 different rooms in Pueblo Bonito alone, and that is not the only structure in Chaco Canyon. So when we think about ancient cultures and peoples, I just want to make you guys go woo a lot. A lot of people tend to downplay their intelligence and their skill sets. These people are incredibly smart. I guarantee that if you and I were to go out with one of the ancient Puebloan folks who built that, they would know significantly more about observing the night sky or the day sky than you and I, unless you're somebody who spends a lot of time out there. All right, go ahead and hit next. Ooh, this is one of my favorites because this one's a lot closer to home. So we're gonna talk about the Lower Pecos. Go ahead and hit next for me. Now, the Lower Pecos region is kind of in what I call the armpit of Texas. All right, it's a little armpit. It's right there. Now, we're gonna focus in on the White Shaman Preserve, which is just outside of Del Rio in a little town called Comstock. It's about 3 hours from here. You could do it as a day trip, or you can go camping at the state park that's right across from White Shaman. And this region has a wealth of archaeological sites. People lived here for thousands of years, from about 10,000 years ago to about 2,000 years ago. And these peoples were moving all across that region, trading with each other and creating art. Go ahead and hit next for me. Go ahead and hit enter. So where do we find examples of Pecos rock art? You have a few different options: caves, pebbles, pottery, or rock shelters. I gotcha. All right. So, the rock shelters and geological formations that we find in the Pecos region are not deep enough, geologically speaking, to be considered a cave. If you'll hit next for me. These are cutouts in the sides of cliff faces. These are what we call rock shelters. They're not very deep, but they do provide some protection from the elements. I've been to these sites multiple times, and it's definitely nice when you get into the shade out of the sun. So this right here is the Fate Bell Shelter at Seminole Canyon State Park, which is one of my favorite state parks. Don't tell the other parks. And you can go and do tours of this site. You can go, I think they do them every weekend, I think 2 or 3 times a day in the fall and winter and spring, and then like once a day in the summer, because it's way too hot to do that any more than that. So these people are living in these rock shelters, moving with the seasons and moving with the times. We also, if you'll hit back for me so we can look at the results again. Yeah. We don't find archaeological evidence of pottery. These people were not making pottery, as far as we know. But we do find painted pebbles throughout the region. These are little tiny rocks that you could slip in your pocket very easily. Don't do that if you find them, though. Tell an archaeologist and leave it where you found it. But these little pebbles are found all over the place. Anywhere you find archaeological evidence of the people of the Pecos, you are going to find painted pebbles. We don't know exactly what they were used for, though, because there are no known living descendants of these people. I have nobody that I can go and say, tell me what this means, because we don't know. If you'll hit next for me, one more time. Now, this is one of the sites that you can visit fairly easily because you can do tours through my former employer, the Whitty Museum. Heyo. Where's the clicky thingy so I can use the... Oh, no. I'm going to use the laser pointer on it. E. If you'll slide that on. Help. I'm useless. Awesome. Okay. I love those little hearts. They make me so happy. You guys like it? Yay. Yes. Okay, so this, like I said, is the White Shaman shelter. You can go and do tours to this site. I believe it's when I worked there, it was $15 a person, which is very reasonable, if you ask me. I will say it's a very tough hike. It's about a mile vertically down and a mile vertically back up. You're scrambling over rocks. So if you do want to do that hike, I suggest doing like lots and lots of squats beforehand. Get your legs ready. I did not, and I could not walk for a week. It hurt. But this site is really, really neat. This is called the White Shaman Shelter. And the reason it's called that is because when European and post-European explorers showed up, people who looked like me, but were men, when they got there, they were like, oh, look at this big figure in the middle. That has to be somebody important. It's a shaman. And then as we continued to do research, both analyzing the paint, doing anthropological research, so looking at modern day peoples with similar art styles and similar stories, the general consensus these days is that this is actually the lunar deity. So not necessarily a shaman, more a god. So we have the figure in the middle with those prominent outstretched arms, long body, and you'll notice there's no head. And we'll talk about that in just a little bit. I want to talk about the whole mural, though. So you will see some figures over here. You'll notice a white line kind of traversing, and it kind of wraps around the top. It's hard to tell in this photo. There are some black dots in the top corner. There are some smaller images throughout the bottom as well. If you trace the path of that white line, what current research believes is that this is the path of the moon as it travels from Dawn Mountain through the sky into the middle of the night and into sunrise and sunset. It is believed that this particular mural is showing the emergence of ancestors from the underworld. We see these dots on the side. Those could be representations of different, oh my gosh, stars, duh. Different stars in the night sky. And so again, we see a lot of connections or current understandings with the night sky, right? We have the lunar deity, we have the path of the moon. So again, why is this an archaeoastronomy site, Sam? Because on the winter solstice, the sun rises and illuminates exactly where that head would be. Again, is this coincidence or is this intentional? There's nobody that I can go and ask. So we have to use our anthropology, archaeology, and other sources to figure this out. One of the other really neat things about Pecos rock art, in my personal opinion, is the way this art is made. It uses mineral pigments to create those different colors. So it doesn't use plants or anything. That is different minerals combined with animal fat and saponin from a few different plants, actually. And that saponin, that animal fat, and that ground up paint or mineral creates this paint that has lasted thousands of years. One of my favorite things to do when I was working at the Whitty Museum and teaching programs about this was telling kids, I need you to go outside and make me a paint that will last 4,000 years. And they would stare at me like, what? And that's exactly what these people did. So again, these people are incredibly connected with the land around them, with the sky around them. They are connected with the natural world in ways that we, unfortunately, are not as much anymore, which I think we should all do a better job of fixing. All right, go ahead and hit next for me. These are some photos from the White Shaman Preserve. I took those one of the times that I stayed at the cabin out there. Beautiful sunrise, overlook of the river. It's incredible. 10 out of 10 recommend. It's one of my favorite places. Go ahead and hit next. There are other examples of archaeoastronomy. Obviously, I only have so much time with you guys tonight. So we have sites in Ireland, Australia, Mexico, all over the world. Peoples for thousands and thousands and thousands of years have been looking up and going, Huh, neat. Go ahead and hit next. So, like I said, it's really cool. Go ahead and hit next for me. Let's look at our leaderboard. Bodie McBoatface. All right. Who's Elsa? Oh. Oh, well, whoever Elsa is, high five. All right, go ahead and hit next. Cheers, y'all.
All right,
if you
what
have
a...
any other questions, you can email me. That's my email.
There you go. That was a fantastic talk. Really cool. Thank you again.
Thank you.
So now, of course, our Q&A session. The number is right on the screen. Or if you want to just ask it, hold on, and I'll get to you once I finish the phone. So the first question, I have this question too. Roughly how big is that mural, the White Shaman mural?
Oh, that's a good question.
Like if you were, I guess if I'm standing next to it.
If it were the wall, that's a good.
Oh, there
Look
you
at
go.
you. Thank you. It's been a while since I went out there. I was last there in 2018, so it's been a minute. From what I remember, it would be from essentially that giant barrel there to about where I am right here. It's a very, very large mural. Oh, one other cool thing about the Pecos rock art. By looking at scientific analysis of the pigments on the wall, we see that they painted one color at a time on the whole mural, which means that they were intentionally planning that out. I am not an artist, but even if I was, I don't think I could do that. Planning out a mural and doing one color across the whole thing. It's super impressive.
Very interesting. The next question is, how far does the rock art dating go? Like the oldest that we can surmise?
That's another good question. I want to say the oldest rock art, do not quote me on this, it's around, at least in the Pecos region, it's around 8,000 to 9,000 years old. One of the other cool things is that the art style has changed. So the oldest rock art is only painted in red. And you'll notice, or if you saw in the photo of White Shaman, it is 4 different colors. So over time, these people were learning new things, trying new pigments, and creating super awesome art.
Very cool. Staying on the subject of age, what is the oldest Archeoastronomy site known to date?
I do not have an answer for that one. That is a very fantastic question, though. Yeah, I don't know. I would have to look that up.
That's fair. That's
Yeah.
fair. This is a good question too, because I know you always hear about it in engineering, where they look back at old buildings and they say, how did they build it so well? So how difficult would it be to replicate these alignment techniques with modern materials and techniques?
Yeah, so if you think about it, these sites are a few thousand years old. People a few thousand years from today will be looking at the structures that we built and going, huh, interesting. So if you are somebody who has a bunch of property and you want to go out and build a really cool like solar aligned building, let me know and we can go make a future archaeoastronomy site.
That does sound fun.
Right?
Leave a mark, All right, any questions in the room? Anybody want to raise their hand and ask a question? Because I've got no more on the phone. Oh, yep.
It's fairly close to Devil's River. It's about an hour and a half drive away, just because you have to go down that super long road at Devil's River to get around to it. But if you look at a map, they're very close to each other.
On the topic of the Pueblo Bonitas, right?
Yeah.
You said it was built around the 1200s.
So archaeological evidence shows that construction on all of the buildings in Chaco Culture Canyon generally started around 850 AD, and we see archaeological evidence kind of ends around 1250. And so different structures were built throughout different periods of that time. I don't know exactly for Pueblo Bonito, though. Yeah. Has anybody here been to that site? I'm so jealous. I haven't been there yet. I hope to someday soon. Awesome. Any other questions for me? Cool. Thank you so much for letting me geek out with you tonight.
Thank you again. All right. Let's get the slides back up. We're going to move on to the trivia. So as those of you that are new, we do trivia here. We have some great prizes up here. Everybody that wins will walk out with a 2022 Night Sky Almanac, which means all, because it's teams, and so everybody in each team will win. We do top 3 teams. We also have other prizes, such as a very nice Blue Star pint glass, NASA stickers, few posters, so interesting prizes. So the way it works is cell phones, of course, are not permitted. I'm going to come around, and my colleague Aaron, we're going to give you all trivia sheets. 2 things, very important. If you need a writing utensil, raise your hand and keep them up until we give you one. If you have one, please use it, because we have a limited amount. So, and then the other rule that's not up there is if you're a student, a science student, you're out. You can play, but you can't submit. You can't win. So. A 75 feet, B 180 feet, C 560 feet, D 1700 feet, or E 3000 feet. And I forgot to say it out loud. Please put down the letter to make it easy on us. Just the letter. Yes, yes, I will. I'm emphasizing. Please. There you go. 75 is A, 180 is B, 560 C, D, 1700, 3000 E. This is a good question. Did you know this?
All right.
We're good? Good?
Everybody good? Next question. What is the name of the small spacecraft that was released during the DART mission designed to keep taking images of the asteroid system post-impact? A, the Lycia Cube, B, Astro Imager, C, the Mica Prism, or D, the Acta Square?
This is a classic memory recall question. We are going to know how well you were paying attention.
And specifically, the spacecraft released from DART.
We all good? Speak up, if not. All right. Question 3, about what percentage of all near-Earth asteroids have moons? 1%, A, B 15%, C 25%, D 50%, or E, all of them, 100%. This is near-Earth asteroids. Near Earth. I can always tell if people are done or not. It's done. Good.
All right. We're going to move on.
Speak up if not.
All right. Next question. When was the white shaman mural painted, approximately? A, 5000 BC, B, 2000 BC, C, 1000 BC, D, 1000 AD, or E, 2000 AD? A, 5000 BC. I will run down the list. Be careful with the letters.
All good? Speak up. All right. Question 5. Which of these is not considered an archaeoastronomy site? Not. A, Misión Concepción. B, Chichen Itza. C, Saucia Observatory. Or D, the Durrington Walls. Which of these is not considered an archaeoastronomy site?
All right. We good? Anybody need some more time? Okay, next question. Which is a bonus question.
We don't have the sixth question today, but you know what? I'm feeling generous because I want to give everybody an opportunity for one. So this is one I was thinking about, 6 questions, so listen carefully. Talked about Polaris and how it was 5 degrees off many years ago. So Polaris right now is the North Star. How many years will it take for it to not be the North Star and then once again be the North Star? So basically, how many years will it take to come back to its current position, approximately? This is an extra bonus. So if you get this one, I'm going to dig out and get you more prizes.
And that's for question 6.
6.
Anybody need that question repeated?
Yes, okay. How long will it take for our North Star Polaris to move back to its same exact location? Because as we have learned during Sam's talk, it was not the North Star approximately 10,000 years ago. So how long will it take for it to get back to where it is right now? How many years? Approximately. So, is everybody good now? We're going to go to the bonus. No, we got the bonus still. That was question 6. Here we go.
All right. So the bonus question is an open response. What are some astronomical objects and events recorded by ancient cultures? Please, one-word answers. You can have multiple answers, but we ask you to have one-word answers. Again, what are some astronomical objects and events recorded by ancient cultures?
Objects and events. Keyword. When you're all done, make sure that your sheet has a team name. Bring it up to us. And if you borrowed a writing utensil, bring that with you as well, please. Do we have any outstanding sheets out there? Are we all in? Nope. No. Our prize winners tonight is one of the people that, for question 6, my question about the time, did not put units. So I'm a little sad inside, but you know. Huh? Honestly, I mean, if we were in school right now, no credit. No credit. But we charge along. All right, so the first question was about the size of the asteroid.
That was impacted by DART.
The answer was C, 560 feet. So if you got it right, round of applause. Yeah, there you go. Yeah, good job. Woo! I love it.
Give your all a round of applause if you got that unit conversion on the spot.
Question 2 was about the instrument that spit off from the DART.
That's a way to put it.
You know, it's all about, you know. That was yours. A, Licia Cube. Light Italian CubeSat for imaging of asteroids. Huh?
So what was the third question?
Third was the percentage of near Earth.
Oh, yeah. All right, and for the third question, the percentage of near-Earth asteroids that have a moon, the answer is 15%.
If you think about how many asteroids are out there, 15% is a significant number, so this is a good chunk. All right, so moving on to the Archeoastronomy questions. The next one was about the White Shaman mural. How old was it? When was it painted?
How old was it?
2000 BC.
Careful
Answer
with those
choice
letters.
B. Next was which one of these is not. Which one was not a
Oh, yeah. All right, and then the next question was which one was not an Archeoastronomy site, and the answer is the Mission Concepcion in lime green this time.
It is, alas, just a mission. Pretty, just a mission. All right, the next question, we don't have a slide for it because, you know, it came up, was the how long would it take? And one team did get this right, so, you know, this might give away who won the whole thing, but, well, they know who they are. It was 26,000 years. Very good, very good. So in 13, so Earth has a 23-degree tilt from its axis. It's tilted 23 degrees, and this tilt goes around the standard axis every 26,000 years. So 13,000 years from now, the North Star will actually be 23 degrees off of north in the sky.
Which is roughly about Vega, which is one of the brightest stars in the sky as well.
Yep. So if you're alive 13,000 years from now, you get to see that. So.
And if you're in between, you have no idea where you are.
All right, so now for the real bonus, which was about what can you see in the sky, objects or events.
What objects or events were recorded by ancient peoples.
Woo!
Some of the answers are, or most of the answers will be the moon, the sun, the planets, supernovae, and eclipses. So this was multiple answers. And there was one team that got 3 of them, so props to you, and you will find out who you are.
All right. So with that through, it's time to announce the winners. We'll start with third place. We have a tie. It seemed the last 2 events we've had ties for third. So good job, guys. Good job. So everybody in third place is winning a LRO poster, the Lunar Reconnaissance Orbiter, Europa stickers, NASA stickers, and then we only have one of these mugs, so sorry about that. So figure it out. And then Astronomy on Tap stickers. We have 2 of those. Did you get it? Yep. And so the winners are Team Thompson and Beer O'Clock. Come on up, both teams. All right, and then how many of you are there? Because everybody gets one of these, so. 1 for you. 1 for you. Wait. Beer O'Clock. Beer. Each of you, wait, one more. There's 3 of you. There you go. Yeah.
Oh, okay.
With those, yeah. All right, thank you. Second place. Yes. Second place is very ironic because if this is who I believe it is, then they're getting the almanacs back. We've got Robert and what is Anne. Yes, that is an A-N-N-E. Robert and Anne. If you can just give them to 2 nice people. Find 2 people to give them to. There you go. All right, and then let's get our drum roll going for the first #1 prize of the night. Team Not Physicists. Get on up here. There's a lot. How many of you are there? 4. Here's 4. 1, 2, 3, 4, 5, 6, 7, 8, 9.
Yo, what is this book? I want that book.
Did Robert give us all these?
Yes. Everybody should have one. If nobody got one of the almanacs, let me know. But everybody should get one.
Samuel right here. Oh wait, never mind.
That's it.
Yeah, I think
Another round of applause for our first place team of the night. All right, let's. I think it goes around the cup
like a
or
cup.
something.
It goes
and
around
it's
a
a hole.
cup.
It's like a cozy, but it's just for a finger.
Cup, right? Just for. Is that stable?
All right, everyone, thank you so much for coming out tonight. It was a blast having you all. I hope you enjoyed the talks. It was, yes, no. A round of applause for our speakers, Sam Toback, and the recently here, Dr. James Walker. Thank you to the Southwest Research Institute for their support. Thank you to Vincent and Tracy who keep the lights running for this event. As I like to say, they do so much. And of course, the Blue Star Brewing Company for having us every month. Be sure to tip your waiters and waitresses and show some love. And we will see you again Next month on November 2nd, once again, that's the first Wednesday of November, November 2nd, we'll have very interesting talks. Vincent himself may be giving one on Europa, so maybe stay tuned. Thank you for coming. And merchandise, come shop.